Okay, so now that we've wrapped up our discussion of the OWASP Top 10, let's take a moment to talk about the software development process. In general, security is a process, and to implement security effectively over a long period of time, you have to take a process-oriented approach. And in order to do that successfully, you have to understand how to work with any related processes. The software development lifecycle is the general process of building and fixing software. Organizations that are creating software, whether we're talking about web applications, mobile applications, or traditional software applications, usually follow a well-defined process. We call this process the Software Development Lifecycle, or SDLC. The SDLC isn't just about creating new software. It's also about fixing problems in the existing software, as well as adding new features to the existing software. As the name implies, the SDLC is a cycle. Once the end of the cycle is reached, it starts all over again. How long the cycle lasts depends on the type of software development methodology in use. I'll talk more about that in a moment. Now, the SDLC almost always starts with a planning phase. During the planning phase, there's someone responsible for determining what the software development team is going to work on. Usually, this person is the overall owner of the software project and typically has a title like product manager. So, the product manager is responsible for determining which features the application will have and in which order the developers will create those features. The product manager usually has a direct line of communication with the people who use or will use the software. The product manager has to figure out which features the users want most and how much value there is in implementing those features. For existing software, there are always problems or bugs that will be found after the software has been released. The product manager also has to prioritize the work needed to fix these bugs. So, the product manager has to make trade-offs, like deciding whether to implement a new feature that will make the company more money, or fixing bugs that cause problems for the existing customers. And some of those bugs will inevitably be security related. One of the jobs that we have as security professionals is to make sure that the product manager understands the business risk for every known security problem in the application. This way, they can effectively prioritize the work. Now, the product manager spends some amount of time planning which work will be done in the current cycle. The various work items will be assigned to developers, and they will be responsible for creating or updating the software. The developers will analyze their respective work items and then come up with designs. Once they've finalized their design, they'll actually write or modify the software necessary to implement the new functionality or fix the bug. The developers typically hand their completed work off to a quality assurance or QA team that will be responsible for testing the software. The QA team usually runs several different kinds of tests. They'll test the software to see if it meets its basic goals. In other words, if it's for a bug fix, does it actually fix the bug? If it's for a new feature, does it work exactly like the product manager specified? They will also check to see if the software introduced new bugs or accidentally reintroduced old bugs. The QA team will coordinate with the development team and report any issues identified. If there are problems, the developers will often fix the problems and have the QA team test again. Once the tests have passed, the new code will be integrated into the existing code and released for use by the users. The users may identify functionality that doesn't work as intended, which typically gets reported to a customer support team. The customer support team will usually record these issues in a ticketing system so that the product manager can review them and determine the priority for fixing each one. At that point, the cycle starts all over again. Now that we've talked about the general software development lifecycle, let's talk about some specific implementations. There are a bunch of different software development methodologies that can be followed to implement the SDLC, but there are two primary types that tend to be more common, and I'll focus on those. The first one is called waterfall and was very common up until about 10 or 15 years ago. I'll explain how it works in a moment. The other one is called agile, and it's probably the most commonly implemented software development methodology now. As I mentioned, waterfall was probably the most common software development methodology up until maybe 10 or 15 years ago. It worked well for software that only needed to be changed once or twice a year, but with the advent of web and mobile applications, users have come to expect their software to evolve more quickly. Waterfall is a holdover from the days when we used to buy all of our software in stores or from large software vendors. The software vendors followed the same basic steps that we saw 2 slides back, and the cycle usually happened over a span of maybe 6 to 12 months. So the software vendor really only released updates to the software, including new features and bug fixes, once or twice a year. As applications evolved, product managers realized that they needed to fix bugs and introduce new features more quickly. Also, because the software was only being updated once or twice a year, the updates usually included a lot of new code or modified code, and making too many changes at the same time can cause problems. Like, one piece of code might not work well with some other piece of code. So, as web apps grew in popularity and mobile applications started to become a thing, many organizations adopted a different software development methodology known as Agile. There are actually several different variations of Agile, so we'll focus on one that's probably the most common one. It's called Scrum, and it's not quite as complicated as it looks here. At a high level, Agile and Scrum specifically do the same thing as the waterfall methodology. They just do it in much shorter time frames. So instead of going 6 months between software releases, an organization might only go, say, 1 month or even just 2 weeks between releases. Basically, the idea is to work for shorter periods of time and do smaller software releases so that important features and bug fixes can be deployed quickly and so that there are not so many changes occurring all at the same time. Agile methodologies typically specify a different way to run the planning meetings than you would see in a traditional waterfall implementation. For example, instead of having periodic meetings with a whole bunch of people that last several hours, most Scrum shops have a 15-minute stand-up meeting at the beginning of the day where everyone talks about what they'll work on that day. The other thing that they tend to do differently is have the development and testing work happen pretty much at the same time, and sometimes they'll actually make the developers responsible for the testing. Now, the QA testing can't happen until the development work is complete, but each developer might write some code to fix a bug or implement a feature on one day, hand it off to a tester, then work on a different item the next day while the first item is being tested. Now, in practice, different methodologies might have some of the basic phases happening at the same time. For example, planning and analysis tend to happen at the same time. In agile methodologies, implementation and testing can also happen at the same time. There are specific documents or artifacts that are usually produced for the various distinct SDLC phases, and the different methodologies will call them different things. And one of the things that's a little different about Agile is that it's intended to be lighter in terms of documentation. So the waterfall methodology would have people spending a lot of time up front creating a design and documenting everything. And the Agile methodology, is such that the developers kind of tried to get away from doing so much paperwork, essentially. And that allows them to build things faster, but there are some downsides to it too. Nonetheless, even in Agile methodologies, there are certain artifacts or documents that are associated with each phase of the software development lifecycle. For example, during the planning and analysis phase, the product manager usually creates requirements that specify what the developers will do. These could be requirements for new features or for bug fixes. It's common to frame these requirements as use cases. A use case is just what it sounds like. If the product manager wants the developers to build a new feature that allows one user to transfer money to another user, they might create a use case like this. As a banking customer, I would like to be able to transfer money to another bank account by specifying the destination bank account number and the routing number for the destination bank. Now, the use case will probably be a lot more detailed than that, but that's the general concept. During the design phase, the developers might create a diagram, like a flowchart, that indicates how their code will work. Someone in QA may also create a test plan that indicates the types of tests that will be run against the new software to verify that it meets all requirements. Now, in an agile methodology, that might happen a little bit later in the process, but ultimately it still happens. During the implementation phase, the developers will create the program source code that implements the bug fix or new feature. During the testing phase, the specific tests that will be run and the results of those tests will be stored in files or a database. During the maintenance phase, feedback from customers will usually be logged in an electronic ticketing system such as Jira. As security professionals, we need to figure out the best way to address security during each phase of the software development lifecycle. This slide shows the various security controls that we aim to implement in the software development lifecycle. The numbers indicate the priority. So item number 1, code review, should be implemented first, and item number 2, risk analysis, should be done second. When we think about prioritization, we have to weigh two considerations: how beneficial the security control is and how much effort or cost it will take to implement it. So the biggest bang for our buck tends to be code review. When it comes to security, code review refers to the process of checking the code for security vulnerabilities. This can be done manually by people, but people usually do a bad job at this. They might start out really excited, but after an hour of staring at someone else's program code, their eyes tend to glaze over. And it can take many, many hours to thoroughly review program code for vulnerabilities. So it's usually a better idea to use a special purpose software program to check the source code for vulnerabilities. Typically, we would buy a commercial tool like, say, Checkmarks, and have the developers run it when they're done writing their code. If it reports any vulnerabilities, the developer will verify whether the reporting is accurate. If so, they'll fix the issue right away or work with the product manager to determine the correct prioritization. Risk analysis should be the second process that we implement, although most organizations usually skip it entirely. A lot of companies focus on using tools and tend to skip things that require human effort. Unfortunately, there are no software tools that can do risk analysis, at least not the way the term is used here. When we talk about doing risk analysis during the SDLC, it means that someone who understands how the software is supposed to work should sit down with someone who is responsible for security and work together to analyze the software for risks. Usually, this means that someone from the security team will be meeting with a lead developer and maybe the product manager. Typically, the developer will provide a high-level diagram showing how the software component in question fits into the larger picture, and the security personnel will ask questions about things like authentication, authorization, audit logging, and that sort of thing in order to get a feel for where security issues might pop up. This is crucial because it's the main way that we identify business logic flaws. Business logic flaws usually relate to the flow of user interaction, and many of them are related to access control issues. Here's a simple example. Let's say that we're building an online banking web application. We might decide during the risk analysis that it's way too risky to let one person initiate a wire transfer for more than, say, $100,000. We might decide that we'll require two different people at the customer's organization to approve any wire transfer that's over, say, $100,000. Or maybe we'll introduce that functionality as a feature in case customers want to use it. That's the sort of thing that no security tool is going to figure out. The third thing that we should implement is a penetration testing process. This could be an annual process where we have a third-party company test the software. It might also be something that we have internal specialists do during the regular QA testing. Some companies take a hybrid approach where they delegate a specific QA person to handle this kind of security testing with each release, and they also hire a third-party company to test the software once a year. The fourth thing that we should implement is a set of risk-based security tests. This is mostly about taking any potential business logic flaws that we came up with during the risk analysis process and turning them into test plans that the QA team will execute. The fifth thing that we'll implement are something called abuse cases. Abuse cases are just security-specific use cases aimed at highlighting the sort of things that attackers might do. An example abuse case might go something like this. As an attacker, I'd like to use a phishing email to trick an employee at the company into transferring money into my bank account. This ties into the sixth item that we'll implement, which is security requirements. Security requirements are just what they sound like, and their goal is usually to address all of the potential business logic flaws and technical security flaws that could affect the application. These requirements will usually have standard items like use parameterized queries with bound variables for all database interaction, as well as application-specific requirements for preventing business logic flaws. Now you might wonder, why wouldn't we implement the security requirements first? And the sad truth is because most people will ignore them, and so they end up being relatively low value. That's just sort of a sad fact at most organizations. So, the prioritization that we're reflecting here is based on kind of a more pragmatic approach where we take into account the fact that, yeah, it looks good on paper, but doesn't actually sort of work in the real world. So it's a fairly evolved set of priorities here. So the last issue to address is something called security operations. This is more about the operational processes required to keep the software secure after it's been released. This includes things like ongoing hardening, monitoring for new vulnerabilities and fixing them as they're identified, monitoring the logs for signs of attack, as well as implementing and monitoring security tools like web app firewalls and intrusion detection systems.